All right, recording is thinking about starting. We have volunteer for number 1. All right, recording has started. Welcome. It's Tuesday, February 2nd. Let's see. I can do. All right, Julia, I can do the first one. Actually, Julia, do the second one. Antonio, do the first one, since you said the answer earlier, and volunteer for the third one. Katie, go ahead and do the third one. Yep, so looking good so far. The sign of A, so the acronym SOHCAHTOA, so sine is opposite, so A divided by hypotenuse, which is C, A over C, good job. Cosine is adjacent, so B, remember adjacent means next to, over hypotenuse, so C. And then tangent is opposite over adjacent, so A over B. That looks good. Yep, so SOHCAHTOA, yep, that's it. All right, so this is day 1 of 2.03. We got 3 goals. So many, I'm not going to read them. But we're going to do like trig ratios and some other fun stuff. All right, we're being recorded as always. All right, and here is the bell work with expanded. So I don't know if you have learned. So can anybody tell me in your geometry course that you took, I'm guessing sophomore year, did you learn about cosecant, secant, and cotangent? I got some nopes. I got a lot of yeps. Nope and yep. Okay, so maybe half and half. People who took geometry at this school, did you learn about those other 3 trig functions? Okay, so if you went here, you learned about them. Maybe another school or another district or state or whatever, maybe you didn't. All right. It's nothing difficult, right? So sine, we know sine, cosine, tangent, the whole SOHCAHTOA. Cosecant is the inverse of sine. So instead of being opposite over hypotenuse, it's hypotenuse over opposite. Secant is the inverse of cosine. So instead of being adjacent over hypotenuse, it's hypotenuse over adjacent. And then cotangent is the inverse of tangent, adjacent over hypotenuse versus opposite over adjacent. It's pretty simple. So hopefully all of you are writing this down or taking a screenshot because you need to have this in front of you. So sine and cosecant are inverses. Cosine and secant are inverses. Remember that. We're going to be using that this unit, unit 3, unit 4, and maybe unit 5. I haven't looked yet. So again, sine and cosecant are inverses. Cosine and secant are inverses. Tangent and cotangent are inverses. All right. Oh, you know what? And these A over C, I should have actually had a triangle right here. So on this page, I wonder where it went. This triangle should be on that page. I wonder if I cut and pasted it by accident. It sounds like something I would do. So yeah, if you're wondering what these little a, little b and stuff, it was from that image. So sorry. Okay, reciprocal functions. I talked about this on the previous page, how cosecant, secant, and cotangent, the abbreviation for these So cosecant is CSC, secant is SEC, and cotangent is COT. Yeah, it kind of makes sense. This is expanding on the inverse, how we talked about on the previous page, that cosecant was hypotenuse over opposite, secant was hypotenuse over adjacent, and cotangent adjacent over opposite. Well, cosecant, it can also be 1 divided by the sine of theta. So this symbol right here, you learned in geometry, that is the symbol theta. It generally means angle. So we're talking about some angle. So cosecant of theta is equal to 1 over the sine of theta. Secant is 1 divided by cosine, and cotangent is 1 divided by tangent. So this page is very important. I would definitely write this down because we're probably going to use this in some form for the next 3 units. So make sure you know, obviously, the ratio and the fact that cosecant is 1 over, well, sine, and so forth. Any questions so far? All right. This is going pretty good. We haven't done anything yet, right? Okay. All right. So just like bell work, we're going to fill in these ratios. So the sine of theta, well, we know that is opposite over hypotenuse. So we should have 4 radical 19 in the numerator, and what goes in the denominator? Well, we got some 23s. I think 23 probably sounds right. All right. Cosine, what goes in the numerator? Got some 15. I got a 15. People are saying 15. I like it. And then denominator, 23. I like it. This is easy, right, guys? Nothing hard so far. And then the last one in this column, tangent. What goes on top? 4 radical 19. Yep. And the denominator? 15. All right. All right. Pretty easy. Now let's go back up to the top to cosecant. What goes in the numerator for cosecant? 23. What goes in the denominator for cosecant? Ooh. Yeah. That's weird how it's an inverse, right? Weird. And then cosine. What is that fraction? Go ahead and write the entire fraction in the chat, please. Got some 23 over 15s. All right. I should have mixed them up, and we can probably guess what is this last one here, right? So nothing tricky. As long as you all know that sine and cosecant are inverses, cosine and secant are inverses, tangent and cotangent are inverses. As long as you know that, you're good. Any questions on this page before we go on? I don't think. Okay, good. So we're going good. We're almost done with this lesson already. Look at this. Okay, so we got to practice. We got to round to the nearest thousandths. So first question says, what is the value of cosecant of 23 degrees? Well, here's the problem. You can't type in cosecant in your calculator. So what do we have to do first? We got to switch it somehow. Switch it how? Switch it to, some people are saying sine, some people are saying cosine. So it looks like somebody's saying 1 divided by sine. So cosecant, what trig function is the inverse of cosecant? Sine is, yep. And let's see if my writing works today. It should, because so we should have 1 divided by the sine of 23. And we'll just pretend that's a nice solid line. So yeah, sine is the inverse. Well, 1 divided by sine. So it's important that top of your head, you know cosecant and sine are inverses. Cosine and secant are inverses. Tangent and cotangent are inverses. So that should be pretty easy if you think about it. Going from cosecant to sine, only one of them has like the prefix co, right? Cosine and secant, sine and cosecant. So hopefully make that connection between those two.
Emily has a question.
What's the question?
Shit, never mind, actually. My bad.
Okay. And we got to make sure that we are in degree mode on your calculator. Let me I didn't write the answers down for this, and I want to make sure that we are doing these right. Trying to find my glasses. So we got to make sure we are in degree mode. And we are doing 1 divided by the sine. And I see in chat people have 2.559. That is correct. 2.559. And it does say round to the nearest thousandths, 10 to the thousandth. That is 3 decimal places. So that answer is 2.559. That is correct. All right. So, Emily, what did you get? Yes. So, this is important. Everyone should be typing this in and not just relying on the answer, because if your calculator is in radian mode versus degree mode, or vice versa, depending on the problem, your answer will be so wrong. So everyone should be typing in right now to make sure that you get 2.559. All right. So, Emily, which calculator do you have? All right. That's easy to tell you then, because it's the one that I got. All right. So I want you to hit this the second key. And then the top right, there is a button called Setup. So hit Shift, Setup. It's this top one here and this one right here. So when you go to the Shift, you go to Setup, it's going to have a bunch of options. Option 3 is degree, and option 4 is radian mode. So because we're doing degrees, you want to hit the number 3. Got it? All right. Now go ahead and type it again and make sure you get 2.559. All right, so everyone's good? Everyone got the same answer? As you should panic. Math is life or death. All right, so what is the value of cosecant of 5 pi over 12? I'm sorry, that's number 3, not number 4. We'll do number 2 first. All right. What is the value of secant of 49 degrees? So it looks like we have to convert it, do the inverse. So 1 divided by cosine 49. Does anybody want to write that for us? Danica, go for it. Basically what I wrote for that first one, you're gonna... Hey, your pen is thicker than mine. Why is that? I probably chose, okay. All right, everyone agree it's 1.524. I'm not going to type it in. I'm going to go with the majority, and hopefully you guys rounded it correctly. 1.524. All right, good, good. All right, so number 3. If you notice 5 pi over 12, that is in radians. So all of you need to switch your calculators from degree mode to radian mode before typing it in. It makes a big difference. And then cosecant is 1 divided by what? Yep, 1 divided by sine. Yep, cosecant becomes sine. And then we're doing 5 pi over 12. And we're rounding to the nearest thousandths place. I actually should have done a wavy symbol and I forgot, but yeah, it means about. What's the question, Dianica?
Can you hear me?
Nope. Yep.
Okay, so for the 5 pi over 12, can I multiply it by 180 over pi, and then it gives me 75, and then I could do 1 over sine 75? Okay.
That works too. Let's see if we get the same answer. Let's see. We should. 1 divided by sine. Oops. Make sure you're in radian mode. I almost forgot to switch mine over. 1 divided by sine. So if you're using the Casio, you want to make sure you use that fraction button, and then we want to type in 5, and then the pi, you want to hit shift, and then the pi button is on the very bottom, which is that key there. Hopefully you can see it. So 5 pi over 12. All right, and then make sure you give me decimals. So if you have a Casio, it's going to give you the exact answer, which is radical 6 minus radical 2, but we want decimal form. What is that decimal form? What is the answer? 1.035. Remember, thousandths place. That's 3 places. All right, Chloe, if yours does those, I'm guessing you have a TI Inspire or something, or an 84, then you can do that. That is totally fine. If your calculator does it for you, do it that way. But make sure you at least know the conversion. You need to know that, because when we start doing equations and we're solving, we're going to have to use trig identities and switch stuff around. So you at least need to know the conversion. Whether you use it or not on your calculator is up to you. So we got 1.035. 1.035. Okay, and the last one. Everyone go ahead and do that. So when you type it in, what do you get? So a lot of people saying undefined. And there's a reason for that. So I'm just going to use the undefined symbol. That means undefined or no solution. So we're going to learn about this. I don't know if it's later this unit or if it's next unit. It's probably this unit, the unit circle. So tangent on the unit circle, you're taking it's y divided by x. That's the ratio for coordinates. And pi over 2 is 90 degrees. So you think about 90 degrees is that coordinate is 0, 1. So x is 0, y is 1, and 1 divided by 0 is undefined. So mathematically, that's kind of what's going on, but we're going to learn about that later this unit. But yeah, it's undefined. Yep, all of you should get undefined, whether you do tan of 90 degrees in degree mode or tan of pi over 2 in radian mode. You get undefined. It's always your fault. All right. All right, let's do some more stuff. So we are going to write the ratios of this. So these two are for this first triangle. These two are for the middle triangle. And then these last two are for this triangle. So we're just going to set it up. So for example, on the sine of A is going to be opposite over hypotenuse, so 8 divided by 14. And then we would reduce that to be 4 over 7. And why I didn't write the reduced form, I don't know. All right, let's give you guys a couple minutes to do this. Let's say, I think 2 minutes is probably enough to get all 3 of these done. Well, 6, but 3 triangles. All right, 2 minutes.
Danica, let me try to explain that really quick. So the adjacent of C here would be this right here. And then the opposite of C would be this. That makes sense?
Yeah, so this is saying the sine of angle A. So remember, in math, capital letters, lowercase letters, they're different things. So this is the sine of angle A. That's why it's opposite over hypotenuse. The cosine of angle B. So now our point of reference is now this angle here. So cosine is adjacent. So adjacent is the 8, and hypotenuse would still be the 14. Hopefully that kind of clears it up.
Did you uncover one on purpose?
I did, yeah.
All right.
Only because I talked about it, and then we had to reduce it. Are they all uncovered for you guys?
For me, they're covered.
Never mind. Never mind. I see it. All right, so I'm going to quickly just uncover these because I want to go on to the next page, which is more important than this one. Because we've already done these. I didn't use the Pythagorean theorem to solve. I just put the length of AB. But yeah, you would use a squared plus b squared equals c squared to find that missing side. So this cofunction, this is kind of hard to explain, other than here's these ratios. So for sine of the angle is equal to cosine of 90 minus the angle. And then here's the radian form. Cosine is equal to sine of 90 minus the angle. Yeah, these are kind of hard to explain. So let me go ahead and try. In a right triangle, some of you might be more lost after I say what I'm about to say. So all the angles in a triangle add up to what? 180. Okay. In a right triangle, we know that one of them is 90, correct? Yeah. Okay. Some people are still with me. So that tells us that the sum of the other two angles must be what? 90. Yeah, not a trick question. So the sum of those two angles must be 90. So going to this first one. So by saying the cosine is 90 minus the other angle, well, that kind of makes sense because the other angle has to be the 90, which is the total between the two angles, subtracting out one of the angles. I'm confusing myself by saying it. Because we got 90 is total, subtract out one of them, leaves the final angle. I need a picture. I like pictures. So angle A and angle 90, they add up to 90 degrees. So that means angle B is 90 minus this other angle. Angle A is 90 minus the other angle. That's really what these cofunction ratios are. And just saying that angle is 90 minus the other angle. I know it's kind of silly, but that's just kind of what's going on here. It's not necessarily important that you understand why these are, but how to use them. So you want to write these down. I don't have these on the other pages, so please write them down. I'm going to ask you for them because I don't have them memorized and I don't have a printout. Sine, cosine, cosine, sine, secant and cosecant. Yep, they're inverses. That makes sense. Cosecant and secant. Yep. Actually, they're pretty easy. And if you're wondering, pi over 2 in radians, 90 degrees is pi over 2. 90 degrees is pi over 2. So here's the radian form. All right, so let's practice these cofunctions. So what is the trigonometric cofunction of cotangent of 32? Well, let's, you may want to take a wild guess based on that previous page. Don't forget the parentheses, it matters. But yes, you are correct. So that is tangent of 90 minus 32, which equals tangent of, what is 90 minus 32 again? Somebody said it, like 50 something. 58? Yep, sounds right. So if that is the cofunction, and they're equivalent, should 1 divided by the tangent of 32 equal tangent of 58? I think so. Someone type that in. Too much type in. How have you guys type it in? I can't see. They want to verify that's right? I really hope it's right. It is. Just what we learned. So how we can rewrite cotangent as 1 divided by tangent of 32. Hit enter. And then because of these cofunction ratios, we can rewrite it as tangent of 58. So tangent of 58 should equal 1 divided by tan of 32. For both. Crazy. It's crazy. It's how we can rewrite something that looks totally different but has the same value. Math is crazy. Yeah, checks out. So that's fun. Yeah, math. Okay, everyone, go ahead and try the remaining 3. We got a visitor in here? All right, so I'm going to put a timer for 2 minutes. Ready, go. Don't forget, we are just rewriting these. We aren't typing these in. Got another minute left. Ten seconds, everyone. All right, volunteer for the second one on this page. All right, Emily, go for it. How about number 3? Danica, number 3 and number 4. Don't be scared. Remember, being wrong is good. You get to learn from your mistakes. Number 4, volunteer. All right, Antonio, thank you for volunteering. Number 4.
I like how you give me the one I'm most lost on.
Well, remember, it's in radian mode. So the first 2, obviously the easy ones because they're just plain whole numbers, right? Integers. In radian mode, what do we have to do?
You got to convert it to. I'm blanking here. You got to convert it to.
I don't want you to convert it. I don't want you to convert it. I want you to leave it in radian mode. So you can, sure, you can convert it to degrees, do the math, convert it back to radians, but there's really no point.
Oh, thank you, Yulia. That helps a lot.
Yeah, let me everyone stop writing for 1 second. I'm gonna go back to the previous page real quick. Pause the writing. Pause the writing. So on this previous page, this is the degrees, and this is for radians. So remember, pi over 2 is 90 degrees in radians. So all you should be doing is taking pi over 2 minus the given angle. So I don't want anybody to convert these radians into degrees, though you could and it would work. You're just creating a bunch of more steps for yourself. So you should just be typing in pi over 2 minus whatever that angle is. And if you have a decent calculator, it should give you it in the pi format.
That's 18 on the bottom, by the way. My 8, which just came out horrible there, but yeah.
Are we allowed to have a negative for it?
Yes, you can have a negative. Yep. Yeah, so for that number 3, it will be a negative. Now, so you shouldn't have a decimal. So like Antonio, he has something.
4 pi over 18.
Yep, but you forgot the actual beginning part. The secant. Four pi over 18. So does Desmos give you the answer in terms of pi? Anybody who's actually using Desmos? Did it in your head. Let me see if that's even right. Pi over 2 minus 5 pi over 18. 9 minus 5 is 4 over 18. Yep, that's Antonio. Good job. That is correct.
Thank you. Thank you very much.
Dianica, that is also correct. Negative 11 pi over 18. Let me squeeze it in there for you, since it is hard to write in Neuro. Sine of, you said negative 11 pi over 18. You got 2/9 for which one, Emily? The last one? If you type in pi over 2 minus 5 pi over 18. Oh, you got to simplify. You're right. Yep. Yeah, so 4 over 18 becomes 2 over 9. Yeah, we have to simplify. Let me go ahead and... All right. Everyone agree with the other answers? Are we good on these? So one person said yes. Same person said yes. On 3. So let me just quickly do that again. So it should be, so pi over 2 minus 10 pi over 9. So that becomes 9 pi over 18 minus 20 pi over 18. 9 minus 20 is negative 11 over 18. Nope, I agree with negative 11 over 18. Oh, yes. Oh, yes. So if you are, so this is kind of goes back to grade school math. Subtracting fractions, the denominators must be the same. So all of you, really, this is kind of, I don't know, mindless math, but this stuff you just type it in, hit enter, and it should give you the answer. So if you type in pi over 2 minus 10 pi over 9, hit enter, it should give you negative 11 pi over 18. If your calculator doesn't give you that answer, you probably need a different calculator. Or you need to do it by hand. Yeah, go ahead, sir.
Wait, can you hear me okay?
Yep.
Okay. So on my calculator, I have a TI-30XS, and I don't have the COT SEC or a CSC option on my calculator.
Yeah,
So,
nobody probably does unless you have a TI Inspire or an 84 or something.
okay, so when I plugged in, like for number 3, I just did the pi over 2 minus 5 pi over 18, and I still got the same answer. Is that okay to do, or?
Yeah, that's all we're doing. We're just rewriting the cofunction form. We're not actually typing in sine or cosine or tangent or any of that stuff. We're rewriting the equivalent.
Oh, okay.
What this is. Yeah, that's all this is. Cosine. Cosine. So I think sine is not correct. So going back to this, cosine. Oh, it is sine. Yes. Okay, it is sine. Yep. Cosine becomes sine. Did I mistype something? Nope. Cotangent becomes tangent. Cosine becomes sine. I just think that's so weird. I guess. Anyway. And then cosecant becomes secant. Cosecant becomes, yep, sure does. Okay, they're all correct. Just want to make sure. Yeah, we're just typing the equivalent statement. So the cosine of this becomes sine of negative 11 pi over 18. That's all we're doing.
Quick question.
Yep.
So this is cosine, correct?
It's cosecant.
Or cosecant. Is that the same as sine to the power of -1?
I believe so.
Okay, good.
I believe so. If you want to confirm that, what we can do is, let me answer that question when we're done. We have 2 more slides. I'll answer that when we're done, okay?
That works.
But I'm pretty sure that that's what you said was true, but we got to check. All right, so we good on these cofunction conversions? Yeah, we're just using, so you have to have these written down. Don't memorize them because you'll forget them. Yeah. Oh, I should have covered these up. Whoops. Oh no, pretend they're covered. What am I doing? Let me just, oh, I went a little crazy there. Dun, dun, dun.
I was just panicking to get them
All
covered.
right. Okay, so we are in, you want to guess what mode we should be in for this problem based on this? Actually, I don't think it matters until we actually type it in. Oh yeah, we're going to have the radian and we're going to have a degree answer. So it matters we're in both of them at some point to get both answers. Okay. All right, so cosine of theta is radical 3 over 2, and we want to solve for the angle. Well, I think back to geometry. To get rid of cosine in front of the theta, we have to inverse cosine both sides. So that's what we do. We inverse cosine both sides. Inverse cosine of cosine, they more or less cancel out, and we're left with just theta. So everyone type in, whether you're in degree or radian mode, it doesn't matter because it wants the directions say both answers. So what is the answer in degrees? So make sure that you are in degree mode. Type it in. What do we get? You should get 30 degrees, yes. And now put your calculator back in radian mode and type it in. What do we get? So radian mode, I want it in terms of pi. If your calculator, like the iTrash 11 or whatever you're using, gives it in decimal form, I want it in terms of pi. You can't. So it's limited. I meant the iPhone, whatever, not the iTrash, iPhone. The iPhone's a good phone. So it should be pi over 6. Yeah, so if you type in, you're in radian mode, you type in the inverse cosine of radical 3 over 2, you hit enter, your answer, it should give you pi over 6. If your calculator does not give you that answer in terms of pi, you need to use something else. And this FX, this $15 calculator on Amazon, will do just that. Which one do you want? Directions. Find the value of the inverse function in both degrees and radians according to your calculator. Yep, I want both. All right, so let's look at this other one. Everyone go ahead and solve this. I want degrees and radians. Is this my last page? I have one more page. Oh my goodness. Just more examples. I'll stop after this one. I'll just go to the next page and just show you the work for those, and you can work them out on your own. That way I don't go over time. So I'll say 30 seconds on the timer. Should be enough to do number 11. Instead of changing the setting on the calculator to radians, can't we just convert the degree answer to radians? That would work for this one, yes. That would completely work. So Chloe's saying is, rather than just go through the steps of putting your calculator back in radian mode from degrees, is take your degree answer and just convert it to radians. Do it. Yeah. So to test that, we learned the other day that to go from degrees to radians, we multiply the degrees by pi over 180. So 30 times pi over 180 does equal pi over 6. So that completely works. Neat. Oh, so 30 degrees and pi over 6, we get the same answer? That's crazy. That's crazy. I wonder if this is the cofunction. I wonder if that's the cofunction. Well, actually, it's not. Never mind. Ignore me. It doesn't apply here because we're solving for the degrees, not for. Never mind. Never mind. But yes, it is the same answer. Crazy. All right, it is 11 o'clock. Let me just show you this last page. Feel free to do number 12 and 13 on your own. So number 12, it does not give you nice answers. So the degrees, if you do the degrees and it gives you this negative 40 points, whatever, likely the radians are going to be the same way. It won't give you a nice answer. So in this case, it is okay to write the decimal equivalent to the nearest thousandths, since that's what we've been doing. Yep, nearest thousandths. All right. Well, thanks for coming, guys, and I hope you learned something, and I will see you all tomorrow for day 2 of this lesson.
Can we check that one thing real quick before I leave?